In this video, we are going to look at the length of an arc and the area of a sector. So first, let's start with what is an arc. Now we know the circumference of a circle is the distance around the entire circle, and a piece of the circumference of the circle is known as an arc. So here I have 2 points, P and Q. Now the distance from P to Q along this line here in green will be called the minor arc. This is piece of the circumference of the circle. And the distance from P to Q along this path, which is a greater distance than the one in green, this would be known as the major arc because it's longer. So there we have it. In green, we have the shorter distance from P to Q along the circumference of the circle, which we call the minor arc PQ. And in blue, we have the greater distance from P to Q along the circumference of the circle, which will be the major arc PQ. Now, this point here will be the center of the circle. And we call that point that is the center of the circle O. Now, if I draw a line from the point P to O and from Q to O, well, from P to O will be the radius of the circle. And also from O to Q will also be the radius of the circle. So what we'll end up with is piece of the area of the circle bounded by the arc and the radii. Radii would be plural for radius because we are from P to O, which is the radius, and O to Q, which is also the radius. Now also on this side, we are seeing a larger piece of the area also bounded by the arc, the major arc, and also the radii. So that area here, the smaller area, will be known as the minor sector, and the larger area will be known as the major sector. So there you have it. Now you know a difference between the arc and the sector. So the arc is piece of the circumference of the circle, and the sector is piece of the area of the circle bounded by the arc and the radii. Now where the radii meet at the center of the circle, it forms an angle, and we call that angle theta. So first, let's look at the length of the arc. And we look at the length of the minor arc because we are going to use this angle theta. And this angle theta is facing the minor arc. Now, if I wanted the length of the major arc, I'll have to use the angle that's facing the major arc. And that will be the angle along this part here, which would be 360 degrees take away theta, because we know a full revolution is 360 degrees. So we are focusing on the minor arc and the minor sector. Therefore, we are using theta, the angle facing the minor arc, and it's also facing the minor sector as well. Now, if you think about it, the circumference is the entire distance around the circle. And we know the formula for the circumference of a circle is 2 pi r, which is 2 multiplied by pi multiplied by radius, or pi by diameter. We'll use the 2 pi r formula. So I'm going to put length of arc, and I'll put minor arc. PQ is equal to, and I'm going to put down the circumference of a circle, which is 2 pi r. So that's the entire distance around the circle. But remember, we want piece of the circumference of the circle. So how would we get a fraction of the circumference of the circle? Obviously, multiply the whole, the total, by a fraction. And how are we going to get that fraction? Well, whatever angle this is, we'll take it out of the whole, right? The full revolution, which is 360 degrees. And that's why we're going to multiply the whole circumference of the circle by a proper fraction, which will be theta out of 360 degrees. And that's your formula for your minor arc PQ. Likewise, if we wanted the area of the minor sector, and that'll be POQ. So let's put that down. Area of minor sector. All right, and POQ is equal to, well, the area of the entire circle is pi r squared, pi multiplied by radius squared. So pi r squared. So that's the entire area. But remember, we want piece, which is a fraction of the entire area of the circle. And to get that fraction, we have to multiply the entire area of the circle by a proper fraction. And that proper fraction, again, will be theta, whatever this angle is, out of the whole revolution, which is 360 degrees. So multiply by theta over 360 degrees. Now I know there's another formula for length of arc and area of a sector when theta, the angle, is in radians. But in this video, we are not looking at when the angle is in radians. We are looking at it when the angle is in degrees. So these would be our formulae. So on this page, we have our circle, we have our minor arc PQ in green, and of course we have our minor sector here. So we are going to find the length of the minor arc PQ and also the area of the minor sector POQ. We have our radius as 7 centimeters and our angle theta as 60 degrees. Now in the exam, they usually tell you, what they want you to use pi as. So sometimes they might say use pi as 22 over 7. All right, sometimes they might say use pi as 3.14. Or they might say use pi as 3.142. These are the usual options they require you to use for pi in the exam. So first, let's use pi as 22 over 7. So we have length of minor arc PQ is equal to 2 pi r, that's the circumference of the circle, multiplied by my proper fraction, which is theta over 360 degrees. So you're going to put 2 over 1, multiplied by pi, which is 22 over 7, multiplied by the radius, which is 7, so I put that 7 over 1, multiplied by theta over 360, and theta is 60. So 60 over 360. So here I'll simply do some cancelling. First of all, these zeros will cancel each other out. And then I'll just remain with 6 over 36, and I know 6 is going to 36 6 times, right? So I could say, 6 into 6, 1, and 6 into 36, 6. Then I could see that these 7s will cancel out each other. Then I'll see this 2 could cancel with a 6, or I could say 2 into 22 and 2 into 6. Anyone you want. So I'll say 2 into 2, 1, and 2 into 6, 3. We look, we see nothing else will cancel. So multiplying across now, 1 by 22 by 1 by 1. So that just give it 22 for the numerator. And for the denominator, 1 by 1 by 1 by 3. So the denominator is simply 3. So you are going to get 22 over 3 centimeters. Now, if you want to write this as a mixed number, 7 3s are 21. So you're going to get 7, remainder 1, over 3 centimeters. Now, let's just say you wanted to work the same thing on your calculator and get the answer as a fraction. All right, so here I have my calculator. I'll simply put 2 multiplied by 22, use the fraction button for over 7, multiply by 7, multiply by 60 over 360, so 60, use the fraction button, press it over 360, press equal, and you see you get the answer 7 and 1/3. Now let's just say you're required to use pi as 3.14 or 3.142. I'll go with 3.14. So you're going to take this off. And you're going to use a calculator to do this. So you're going to put equal to 2 multiplied by pi. So that's multiplied by 3.14. And if it's 3.142, the same way you're going to work it out, right? Multiply by radius, which is 7. Multiply by theta over 360. So that's 60 over 360. And you're going to do this entire thing on the calculator. So you're going to press 2 multiply by 3.14 multiply by 7 multiply by 60. Okay, let's put divided by 360. Press equal. You see you get 7.32, so on. Or can I use the fraction button for the 60 over 360? So 2 by 3.14 multiplied by 7 multiplied by 60 and use the fraction button over 3/60. Press equal. 7.32 and so on. So usually when your answer is not exact on the calculator, you're required to write your answer to 3 significant figures. So 7.32, you stop at the 2. After the 2 is a 6. Therefore, the 2 goes up by 1. So you have 7.33 to 3 significant figures. So that's 7.33 centimeters. Now, sometimes you are required to give your answer in terms of pi. So if they ask you to do that, I'm just going to rub off this here. You are not going to use any of these values for pi. You're just going to leave the symbol pi in your working. All right, so we're going to give our answer in terms of pi. So you're going to put 2 by pi by the radius, which is 7, by the theta over 3/60, so that's 60 over 3/60. Now we know multiplication is commutative, which means it doesn't matter which one you do first. So what I'll do, I'll put the pi last. So I have 2 by 7 by 60 over 3/60 by pi. So all you have to do is just work this part out. I mean, you can do it on the calculator or you can cancel. So we'll have 2 over 1 by 7 over 1 by 60 over 3/60 by pi. All right, so by now we should know these zeros cancel, and then 6 and 6, 1, and 6 and 36 is 6. The 2 and the 6 will cancel. So we have 2 into 2, 1, and 2 into 6 is 3. So for the numerator, we'll have 1 by 7 by 1, which is just 7. And for the denominator, we'll have 1 by 1 by 3, which is just 3. So what we'll have is simply 7 over 3 pi centimeters. Now you can leave the answer like this, or you can write this as a mixed number. So 3 could go into 7 2 times, remainder 1. And this would be your answer in terms of pi. Now let's look at calculating the area of the minor sector POQ. So I'm going to put area of minor sector POQ, which is equal to pi r squared multiplied by theta over 360 degrees. Now again, first, let's look at if we are using pi as 22 over 7. So you have 22 over 7 multiplied by the radius squared, which is 7. So that's 7 squared multiplied by the angle theta, which is 60 degrees over 360 degrees. Now, if you want, you can write the 7 squared as 7 by 7 to make things easier. So what we'll have is 22 over 7 multiplied by 7 over 1 multiplied by 7 over 1. So this is your 7 squared here. Multiplied by your 60 degrees over 360 degrees. So by now we know 60 can go into 360 6 times. So 6 into 6 is 1, 60 into 360 6. And then you can cancel any of these 7s. So okay, let's go right here. 7 to 7, 1, 7 to 7, 1. And then 2 into the 22 and 2 into 6. So 2 into 22, 11, and 2 into 6, 3. Not seeing anything else that will cancel, so we can multiply across now. 11 by 1 by 7 by 1. So that's 11 by 7. Let's write that out. So we have 11 by 7 for the numerator. And for the denominator, 1 by 1 by 1 by 3. So that'll just be 3. So what we have is 77 over 3 centimeters squared. Now we can leave the answer like this, or we can write the answer as a mixed number. So first you'll start by saying 3 into 7, which is simply 2. So 3 into 7 is 2, remainder 1. You'll put that 1 right here. So now you'll be saying 3 into 17. So 3 5s are 15. And you have a remainder 2 to make up the 17. So that remainder 2 will go on over the 3. So we'll have 25 and 2/3 centimeters squared. So that's if we use pi as 22 over 7. Now, yes, we can do all this on the calculator as well. using the fraction button and getting the answer as a fraction. Let's erase all of this. All right, so here I have my calculator up. Let's use the fraction button. So 22 over 7, 22 over 7, multiply by 7 squared. So press 7 and the x squared button to square it. Multiply by 60 over 360. So 60, fraction button here, over 360. Press equal. And you see that we get the 25 and 2/3. All right, so we got straight 25 and 2/3 on the calculator, centimeters squared. Now, if they told us to use pi as 3.142, let's see how we work that out. Take this off. All right, so now I'm using pi as 3.142. So 3.142 multiplied by the radius squared, which is 7. So 7 squared. All right, multiplied by theta over 360. So that's 60 over 360. And of course, I'll be doing this on the calculator. So we'll have 3.142 multiplied by 7 squared. So 7, the x squared button to square it. Multiply by, and you don't have to use the fraction button. You can simply put 60 divided by 360. So 60 divided by 360. Press equal, and we get 25.65. So to 3 significant figures, that's just 25 points. Stop at the 6. After the 6 is a 5, so 25.7. So I have 25.7 centimeters squared. Now, if I'm required to give my answer in terms of pi, I'll simply leave the symbol pi and put in all the other values and work it out. So I'm going to erase this. Equal sign here. So I'm just going to put pi by the radius squared. So that's 7 squared by theta over 360. So 60 over 360 degrees. And what I'll do, I'll simply put the pi last. So I'll put the 7 squared first, which is 49. Multiply by 60 degrees over 360 degrees. Then I'll put the multiply by pi last. So this will be equal to, I could put 7 over 1, multiply by 7 over 1, which will be our 7 squared. Multiply by 60 over 360, which is 1/6. But still I'll put 60 over 360 degrees. Multiply by pi. And we'll do our best to cancel. So again, 6 into 60 is 1, 6 into 360 is 6. And there's nothing else that will cancel. So I'll have 7 by 7 by 1, which is just 49. So my numerator is 49. And for a denominator, we'll have 1 by 1 by 6, which is just 6, times pi centimeters squared. Now I can leave my answer like this, or I can write this answer as a mixed number. Now we know 6 8s are 48, so 6 are going to 49 8 times, remainder 1. So 8 times, remainder 1, and put it over 6. And then you put your pi, centimeters squared. And this is the area of the minor sector in terms of pi. And this will bring us to the end of the video. And I hope now you have a better understanding as to how to find the area of a sector and also the length of an arc.